Hello everyone, I am Muhammad Abdullah Shahid from the School of Computer Science with Intelligent Computing major, and today I'm excited to present my capstone project, the Literature Review Summarizer that uses large language models. And my supervisor is Associate Professor Dr. Tan Tin Ping. And over the next few minutes, I will walk you through the motivation, design, and demonstration of this offline tool that turns PDF papers into labeled critiques and also gives rationale. So basically, these days when you are conducting literature reviews, it's a quite labor-intensive and prone to oversight, and it's a quite fatiguing process, and the volume of academic publications doubles every year, and then there is with the increase of number of papers doubling 5 years and even more, there's a lot of burden. Many teams resort to some expensive cloud subscriptions, and they jeopardize data privacy and inflating budgets just to save a few hours. And a built-in offline resource-efficient assistant that runs on a standard laptop will preserve effort and will help with research integrity and will accelerate any path from reading to discovery, all while keeping your data in one place. Is a lightweight offline assistant that keeps data in-house, ensures security, and dramatically cuts review time. It's faster. That would depend on the laptop's graphics, but it's fast enough as compared to the other solutions that we have. And it's not cloud-based, and there's no need for any ongoing subscription on the cloud or any privacy or licensing for that. So the problem statement, key points. So when we are doing manual review, there's a serious bottleneck that delays project milestones by week. I think that is by far the most difficult phase of any research or any type of analysis, which compromises of a lot of PDFs. So the fatigue and bias will often lead to missed critique or strengths and unchecked assumptions based on any task or problem statement that the user is searching. We have certain existing tools, but they rarely provide any basic critiquing that is based on text, and usually they are just text dumps. And this is an offline solution that will tackle high demand for any type of research process or any type of teams that are struggling with audit trials. They have and different varying integrating outputs, and as we know that there is no low cost way to get transparent sentence level insights or any segment level critiques on demand currently. So this solution will provide it's a great solution to this problem statement that we have right now. So the key points of this project is actually it's basically fully automated extraction, ranking, and critiquing from raw PDF files. We only take text into context here, and actually it takes only top K most relevant papers. So it's customizable, so it lets you select the amount of top articles that it selects for critiquing beforehand. So what it does is that it will use an embedding model like mini LM, and then it will compute a score again and again and aggregate it across the whole article, because mini LM has a small token size, and then it will filter out the top K most relevant papers before any critiquing. This is the first step. This is the step before any critiquing. And then it generates concise one sentence rationales that tie each findings back to your research questions. And then it also produces an overall critique, and for that there is a segment extraction algorithm as well inside. to spot high-level segments. So it's a self-contained solution that runs on a standard laptop with no internet connection required, and it's pretty good giving out a so it shows reproducibility and auditability. Of course, we have a built-in history tracking as well inside. So the proposed solution is that the user begins by uploading one or more PDFs. It actually is for a lot of PDFs, of course. So they enter a research question or any type of problem statement that they have, and then they can select how many papers they first want to select, like top K based on their problem statement. So again, I told there that there is an embedding mini LM that we use, and it's a 512 token size. So what we do is that we compute segment by segment and then aggregate it, and then we choose the top K based on that. So we use certain libraries to extract raw text and clean it, and tokenization is there as well. And then we have there's caption sentences and some other non-relevant sentences that are really non-relevant. They can never be relevant to any problem statement, or even if they are given to any model, it would not result with just waste computation. So we have a cipher that is trained to filter out those type of sentences, and then we use mini LM embeddings for each chunk, normalize and average them, and then rank papers. But we also rank papers as well. Of course, we select the top K first, and they're already ranked by cause and similarity to the research question. For segment level analysis, we have a research and grow plus backstitch algorithm, which actually finds the most appropriate sentence for the statement, and then it grows around it because of to maintain coherency. Because when we are doing the overall critiquing of the large article, we will make it very short, since we have limited hardware and the models we are using are not that large as compared to the bigger models. So we have to be careful with those type of things. And we have for sentence level analysis, we also have a rationale generation. For that, we use a quantized LoRa adapted FYP model, and we use Roberta for classification of sentences as well, for tagging them as weakness, strength, or a gap based on the problem statement. And finally, we use a quantized FYP that we downloaded from Hugging Face to generate the segment level critiques, the overall critiques for each article. And there is, of course, Flask HTML interface. So this is the overall architecture that we have. We have a user front end, we have JSON results, and we have the sentence service, segment service, and better, cleaner entry taker as well. This is a sentence level pipeline. We input first and clean up. Then there's, of course, there is relevance filtering, there is classification and rationale, and then there's output. This is the segment level. There's the seed and grow algorithm here. There's chunk embeddings with mini LM. We extract the segments, and then we use the critiquing. The FYP we haven't trained with any LoRa adapters, because FYP is a very large model for me to train on a simple GPU on a laptop, and I would need a lot of data. With the limited data availability, even if I'm creating a synthetic curated one, I would lag, and I would make the model very biased, not generalized well on the overall data. So basically, it's very efficient. It would cut days of manual review down to minutes and of automated analysis. It's very transparent. You can trace every result from the original sentence. Of course, it's fully offline, so of course your data is on your laptop. There's a history for reproducibility, and of course it supports the Sustainable Development Goal 4, which is by giving students and educators or any researchers, like for educational purposes, AI-powered insights. And basically, we target markets, university libraries, independent research consultancies, and biotech R&D teams. And we can start with the freemium desktop, then go to pro subscription, then go to enterprise and API custom integrations. And of course, for competitive edge, it's offline end-to-end pipeline that runs on a standard laptop. And if you look at the roadmap, we could start, of course, from the university pilots that do team subscriptions. Then we will, of course, roll it as an enterprise-ready model, our enterprise-ready project. So I will be demonstrating the project first. So as you can see over here, that I will show you some of the data that I use, synthetically curated data that I have. For example, this is for Alberta, and this file is core, mixed, and near miss, and paraphrase sentences. So we have to cover all of these angles when making the synthetically curated data. Even if I'm using ChatGPT, and I would have to analyze all the sentences and then make them different again and again by prompting. And also this is the one for LoRa adapter as well, and I have one for the sentence classifier as well. So this is about core. This is a simple, this one will be the straightforward examples, like that. These are always straightforward. And then we have paraphrased ones, we have the jargon heavy ones, and then we have curriculum tiers that are basically more curated towards that. And then we have near miss cases as well to show the model all of those examples, and they are all synthetically created and curated examples. So this is for Alberta. We trained that in 2 steps. So the first step, we don't show the noise, and then the second step we show the noise, and then we download the model and we use it. And this is for the FYP LoRa adapter. And then we, of course, we quantize it. We actually take this and then we use LLama, and then we quantize and then use the model. So this is the beginning, that we classify the sentence as relevant or not relevant, and this is for that. And all of these are tested as well. These are all tested later on, basically on unseen data as well, always. So there's always testing for that as well. And then this is the project. So for example, I can just go to the history and show directly what is in the past. So basically this is the front page, as it can be seen over here. These are the existing uploaded PDFs, and you can also insert more, and you can also insert a simple database. So what I'm going to do is that I'm going to go into the history now, and if I go to the history, we have these all previous problem statements and sentences, all the analysis, like those were saved based on the problem statement. So for example, if we go here, we have this, we already had the problem statement, right? We had this problem statement: classify a text based on the presence or absence of subjectivity, emotion, or bias. Classify sentences or paragraphs. It all basically text classification based, because I'm just testing on those domain of models here, but it can be anyone here. So it's just for reproducibility that I have that here. So this is a sentence. It can be a bigger one as well. In this case, for example, here, so it's labeled as a gap, and there's a rationale. The sentence presents factual information without personal opinion or emotional language. So there's a weakness as well here. This sentence highlights a limitation that could undermine the results. Within the prompts, we use variables such as news. So as you can see, that this one is labeled as a result, their proposed models Senti are achieve state-of-the-art performance on several sentence and aspect level sentiment class. So it's a strength, because the sentence presents factual information without personal feeling or bias, hence its objective. So this is basically generated by a FYP quantized model here. And now I'm also gonna go back to the history, and also this is the segments. I'm gonna show the segments as well. So if you go to the segment, and these are the scores as well. So basically all of these analyses are boxes of articles, and they are ranked based on, this is the score I talked about before. And these are the contextual critiques generated based on these segments. So basically the whole article is extracted, and then the critiques are generated. There's a strength, and then there is weaknesses based on the problem statement. We have that. This is Phi 3. This is not be trained, and we have just used careful prompting and giving it segments and feeding it problem statement to generate it. That's it.